Question 1. The fundamental question is, a media company deployed a load balancer to distribute client requests among several backend servers hosting dynamic content. However, users frequently report session timeouts and inconsistent experiences when submitting forms. Upon closer examination, engineers discover that a user's session data is sometimes lost between form submissions. What should the application delivery team prioritize implementing to address issue A? Configure SSL flooding on the load balancer. B. Enable session persistence using source IP hashing. C. Set a DNS load balancing with round robin. D. Replace dynamic content with static pages. Answer. Correct answer. B. Enable session persistence using source IP hashing. Explanation. Session persistence, also called stickiness, ensures that all requests from a client during a session are sent to the same backend server in dynamic applications like form submissions where session state, e.g. login status user selections, is held in memory on a server. This is critical. Without persistence, a user's request may be routed to a different server. The session context, leading to failures like form resets or timeouts. Source IP hashing is one method that maintains client-server affinity based on the client side. SSL flooding helps with performance but does not fix session-related logic. DNS load balancing C is too high-level and lacks session context. Replacing dynamic content with static pages D is not feasible for interactive applications. This scenario reflects key application delivery principles such as load balancing, session persistence, and user experience assurance. Question 2. In the context of cloud deployment strategies, a healthcare organization intends to shift part of its patient management application to a public cloud while retaining sensitive patient databases on premises due to compliance with data privacy laws. Which cloud model most appropriately supports this hybrid approach? A. Public cloud. B. Hybrid cloud. C. Private cloud. D. Multi-cloud. Answer. Correct answer. B. Hybrid cloud. Explanation. A hybrid cloud combines both public and private cloud infrastructures, allowing organizations to retain sensitive workloads on premises while offloading less critical components to the public cloud. This is especially beneficial in healthcare where regulations like HIPAA or DDoS require strict data residency and security controls. Public cloud offers scalability but may violate compliance for sensitive records. Private cloud C does not leverage the scalability benefits of the public cloud. Multi-cloud D refers to using services from multiple cloud vendors, not necessarily integrating private and public environments. This question tests understanding of cloud computing models in application delivery contexts and the compliance-driven rationale behind strategic deployment decisions. Question 3. Through the lens of performance optimization, which of the following techniques is most effective in reducing server load while improving user experience when serving HTTP requests for the same content? A. Implementing client-side form validation. B. Activating TLS 1.3 for all encrypted communications. C. Utilizing reverse proxy caching mechanisms. D. Enabling persistent TCP connections. Answer. Correct answer. C. Utilizing reverse proxy caching mechanisms. Explanation. Caching, especially reverse proxy caching like Varnish, EDNX, or Squid, stores frequently accessed content closer to users or at the edge of a network. This reduces the need to fetch content from the origin server every time, improving latency, bandwidth usage, and server load. Client-side validation helps reduce back-end validation calls but doesn't repeat content delivery. TLS 1.3b enhances encryption and handshake efficiency but is unrelated to caching. Persistent TCP D optimizes connection reuse but doesn't eliminate redundant content fetching. This falls under application acceleration and optimization, where reverse proxy caching plays a pivotal role in HTTP performance strategies. Question 4. As demonstrated by a recent incident, Keiko, a network engineer, noticed a sudden surge of incoming packets targeting port 443 across multiple data center regions, leading to application latency and denial of service for legitimate users. What should Keiko prioritize to mitigate this threat within the application delivery infrastructure? A. Replacing SSL certificates with longer expiration dates. B. Deploying a SICK hole. C. Configuring a web application firewall WAF with rate limiting. D. Upgrading Techito to handle parallel streams. Answer. Correct answer, C. Configuring a web application firewall WAF with rate limiting. Explanation. The pattern points to a DDoS attack, particularly a Layer 7 application layer flood. Implementing a WAF with rate limiting allows the filtering of excessive traffic from potentially malicious IPs or sessions while allowing legitimate users to connect. Replacing SSL cert, say, has no relevance to traffic search. ENS Syncolin B helps with botnets but not direct application level footage. D is a performance protocol but won't prevent abuse. This aligns with application security, specifically DDoS mitigation through intelligent traffic control mechanisms. Question 5. Examining the consequences of improperly configured NAT in an enterprise environment, how might this affect the application delivery performance or security posture? A. It could cause session persistence to function improperly due to source IP masking. B. It will allow easier DNS-based routing across multiple regions. C. It prevents SSL termination from occurring at the application gateway. D. It enhanced TCP connection reuse, improving performance. Answer. Correct answer A. Could cause session persistence to function improperly due to source IP masking. Explanation. Network address translation NAT alters the source to destination IP of packets. When source IPs are masked, session persistence mechanisms like source IP hash may break as the load balancer sees a single IP from a NAT device. This can lead to poor user experience due to inconsistent backend server mapping. ENS routing B is unrelated. SSL termination C isn't affected by NAT unless IP-based policies are misconfigured. TCP reuse D is managed differently. G via multiplexing. Understanding NAT impacts on load balancing is critical in the networking and protocols domain of application delivery. Question 6. Taking into account fault tolerance and high availability, which configuration best ensures minimal downtime in case a data center becomes unavailable due to a natural disaster? A. Load balancing with session stickiness in a single availability zone. B. DNS failover using GLB across multiple geographically separated sites. C. Vertical scaling of application servers within a single location. D. Enabling HTTP compression for faster data delivery. Answer. Correct answer. B. DNS failover using GLB across multiple geographically separated sites. Explanation. Global server load balancing GLB enables geo-distributed failover, allowing DNS to route users to healthy data centers during outages. This supports disaster recovery and hard goals. Stickiness A is local, vertical scaling. C is a single point of failure. HTTP compression. D improves performance. Availability. This question falls under high availability and fault tolerance in application delivery fundamentals. Question 7. To illustrate this point, Esther Alvarez, an application delivery specialist, is tasked with improving content delivery to end users scattered globally. The company's origin servers are based in Singapore. What should Esther Alvarez propose to best minimize latency for users in South America and Europe? A. Upgrade all backend servers with faster SSDs. B. Deploy Content Delivery Network CDN. C. Increase the TLS handshake timeout. D. Implement subnet-based routing in the data center. Answer. Correct answer. B. Deploy a Content Delivery Network CDN. Explanation. CNS replicate and cache content across a global network of edge servers. For geographically distant users, this reduces latency, avoids intercontinental routing, and boosts performance. Faster SSDs, they help local response time but not global reach. TLS timeout changes. C. Don't address latency. Subnet routing. D is local. This is application acceleration and optimization within global delivery contexts. Question 8. The correlation between application security and authentication reveals that simply using a login form without transport security opens which major vulnerability? A. Cross-site request forgery CSRF. B. Injection attacks. C. Credential interception through man-in-the-middle. D. Distributed denial of service DDoS. Answer. Correct answer. C. Credential interception through man-in-the-middle. Explanation. with the SALS encryption, login credentials set at CHIP be intercepted by attackers using packet sniffers or man-in-the-middle (MITM) tactics. This compromises user accounts here. A involves session hijacking through trusted users. Injection. B targets unsanitized input. DDoS. D overwhelms services. The application delivery security model map TLS for all authentication endpoints as a best practice. Question 9. In what ways can proper routing configurations in an application delivery network impact the functionality of web services relying on real-time data feeds? A. They increase header size, degrading load balancing. B. They may cause asymmetric routing, leading to packet drops. C. They force NAT traversal, breaking application logic. D. They require TLS decryption at the client. Answer. Correct answer. B. They may cause asymmetric routing, leading to packet drops. Explanation. Asymmetric routing happens when outbound and inbound packets take different paths, confusing stateful firewalls or load balancers, resulting in dropped sessions or broken feeds. Header size. A is irrelevant. NAT traversal. C is more about peer-to-peer apps. TLS decryption. D is unrelated here. This relates to routing and switching basics critical in application delivery infrastructures handling real-time services. Question 10. The effectiveness of using TCP connection multiplexing is most notable in which scenario? A. Encrypting multiple sessions with different ciphers. B. Sharing a single TCP connection to handle HTTP requests. C. Creating multiple tunnels for each user request. D. Using IPFA to improve routing paths. Answer. Correct answer. B. Sharing a single TCP connection to handle HTTP requests. Explanation. ECP connection multiplexing allows multi-HTTP requests to be sent concurrently over one persistent TCP connection, especially HTTP. This reduces overhead, improves speed, and conserves resources. Different ciphers. A. Relate to encryption negotiation. Multiple tunnels. C. Increase complexity. D. Improves addressability, not multiplexing. This technique belongs to application acceleration and optimization. Question 11. From a practical standpoint, Ista Ibrahim is troubleshooting a high-performance web application hosted in a virtualized environment. The users report delays when retrieving media-heavy pages, especially during peak hours. The backend server logs show no performance bottlenecks. He suspects the problem lies in the network transport layer. What could be the most effective solution to address latency and reduce overhead? A. Enable TCP connection multiplexing. B. Activate IP funneling to reduce packet loss. C. Implement GLB split traffic regionally. D. Deploy microservices architecture for modularity. Answer. Correct answer. A. Enable TCP connection multiplexing. Explanation. ECP multiplexing, especially where HTTP allows multiple streams over a single connection, reducing handshake latency and resource exhaustion during high concurrency. If backend logs show no delay, transport overhead is likely the cause. B. Doesn't directly resolve latency. GLB. C. Is useful geographically but not in localized congestion. Microservices. D. Improve development but don't directly affect transport efficiency. This ties into application acceleration and optimization through efficient transport layer tuning. Question 12. Under the assumption that a company is hosting its DNS services internally and notices a sudden spike in unresolved queries during application deployment, which could lead to failure in service discovery, what should be investigated first? A. Load balancers session timeout misconfiguration. B. DNS caching expiration and recursive resolver issues. So HTTP header mismatches at the CDS level. D. TLS cipher negotiation delays between endpoints. Answer. Correct answer. B. DNS caching expiration and recursive resolver issues. Explanation. Unresolved DNS queries often stem from expired ENS cache, misconfigured recursive resolvers, or R2L settings. With it, DNS resolution, application endpoints cannot be discovered, leading to downtime. Session timeouts. A. Relate to client-side persistence. HTTP header issues. C. Affect rendering, not resolution. TLS negotiation. Causes delays, but not total resolution failure. This is a critical part of DNS functionality and records, a core piece of application delivery fundamentals. Question 13. In light of recent developments, is JER implemented? A WAF rule set to block any requests with specific payload signatures indicating SUL injection attempts. However, despite the configuration, malicious actors are still accessing the application with obfuscated SUL payloads. Which approach can enhance the effectiveness of the WAF? A. Increase the encryption key size. B. Enable deep packet inspection and behavioral heuristics. C. Modify DNS records to point to dummy servers. D. Set a lower TTL for load balancer persistence cookies. Answer. Correct answer. B. Enable deep packet inspection and behavioral heuristics. Explanation. Obfuscated attacks bypass simple signature rules. Deep packet inspection (DPI) and heuristics allow WAFs to detect abnormal patterns and logic, not just known strings. The encryption key size A improves data confidentiality, not detection. DNS changes C will cause routing issues. Persistence TLS-D are unrelated. This reflects application firewall WAF effectiveness in application security, especially for adaptive threat mitigation. Question 14. By evaluating two common deployment strategies for application delivery, which method provides better horizontal scalability and fault tolerance without significantly increasing operational overhead? A. Load balancers operating in active-passive mode. B. DR-based round-robin without health checks. C. Layer 4 load balancing with health monitoring. D. Single-node server deployment with failover script. Answer. Correct answer. C. Layer 4 load balancing with health monitoring. Explanation. Layer 4 transport layer load balancing is efficient for distributing traffic based on to CPUD, and when paired with server health checks it allows for seamless scaling and failover. Active-passive A. Limits resource usage. Round-robin B. Without health checks leads to dead server routing. Single node with script D. Lacks real resilience. This addresses scalability and performance in load balancing strategies for application delivery. Question 15. The contemporary view of optimizing client-server interactions focuses heavily on protocol evolution. Which protocol enhancement directly supports improved parallelism, compression, and header efficiency, resulting in faster web content delivery? A. Cheeto B. TLS 1.2 C. FTPE SAP or EE? Answer. Correct answer. Cheeto Explomatia Cheeto introduced multiplex trees, HBAC header compression, and server push, all essential to reducing latency and improving resource load times. TLS 1.2 B enhances security but lacks compression benefits. FTP-C is not optimized for modern content. SAP D handles email, not web delivery. This question belongs under application acceleration and optimization, focusing on transport protocol advances in web delivery. Question 16. The central argument for adopting SSL flooding in application delivery infrastructure is centered around what core benefit? A. Improved DNS lookup performance. B. Enhanced visibility into encrypted traffic for policy enforcement. C. Faster packet switching at layer 3. D. Reduced firewall rule complexity. Answer. Correct answer. B. Enhanced visibility into encrypted traffic for policy enforcement. Explanation. SSL offloading decrypts traffic at the load balancer, allowing deep inspection, policy enforcement, and monitoring before forwarding to backend servers. DNS performance A is unrelated. Layer 3 switching C is network focused, not app delivery focused. Firewall complexity D is not directly addressed. This lies within SALS encryption. Security policies critical to application delivery security. Question 17. The validity of health monitoring in a load-balanced system lies in its ability to do what? A. Prevent application layer attacks through user agent filtering. B. Enable GTRE-only access to improve protocol compliance. C. Identify unresponsive backend servers and route traffic elsewhere. D. Increase bandwidth dynamically per application demand. Answer. Correct answer. C. Identify unresponsive backend servers and route traffic elsewhere. Explanation. Health checks ensure that only live, responsive servers are used by the load balancer, thereby preventing user requests from going to down or unresponsive nodes. User agent filtering A is unrelated to health at GT3. B is a protocol enhancement. Bandwidth scaling. D is HCOS or network layer task. It tests concepts in server monitoring under the load balancing section of the exam. Question 18. Among the various load balancing deployment modes, which one involves the load balancer acting as a transparent intermediary and visible to the backend server? A. One-arm mode with snap. B. Inline mode with full proxy. C. Direct server return DSR. D. Bridge mode using VLAN tagging. Answer. Correct answer. C. Direct server return DSR. Explanation. DSR allows responses to bypass the load balancer, with the load balancer not altering packet headers. It offers high performance but limits certain features like SSL offloading. One-arm uses snap visible to servers. Full proxy. B means the LB terminates and reestablishes connections. VLAN tagging. D relates to switching no LB mode. This falls under load deployment modes in application delivery fundamentals. Question 19. The primary reason for implementing AE in a mobile-first enterprise application is to A. Optimize back-end database queries for analytics. B. Deliver device-specific content from edge locations. C. Automate software container deployment. D. Increase visibility into syslog messages. Answer. Correct answer. B. Deliver device-specific content from edge locations. Explanation. CDNS optimize delivery by serving content, including device-adapted assets, from edge servers close to users. This is vital in mobile-first designs with varying screen sizes and network speeds. Back-end optimization. A is unrelated. Containers. C relate to DevOps. Syslog. D is about monitoring. This is core to application acceleration and optimization using CDN strategies. Question 20. The growing trend in containerized application environments has introduced new challenges in application delivery. What is the most appropriate method to ensure visibility and load distribution across dynamic microservices? A. Configure static routes to each container. B. Implement a service mesh with integrated load balancing. C. Deploy a separate firewall per container. D. Assign unique public HIPs to every microservice. Answer. Correct answer. B. Implement a service mesh with integrated load balancing. Explanation. Service meshes, e.g., Istio manage communication between microservices with features like internal load balancing, traffic shaping, and observability. Static routes, they are infeasible with dynamic scaling. Firewalls per container, C, are inefficient. Public HIPs, D, create unnecessary exposure. This falls under cloud and virtualization in the application delivery fundamentals exam. Question 21. The correlation between session persistence and user experience becomes evident in e-commerce platforms where users frequently abandon carts due to inconsistent page states. Ista D'Souza, platform architect, notices that users switching between product pages occasionally lose their shopping cart data. All back-end servers are stateless. What is the most suitable persistence method to resolve this without violating stateless design? A. Enable SSL session ID persistence. B. Use cookie-based session persistence. C. Store session data in local server memory. D. Disable session persistence to allow stateless routing. Answer. Correct answer. B. Use cookie-based session persistence. Explanation. Cookie-based persistence allows the client's browser to store session state information, maintaining the stateless nature of back-end servers. This preserves shopping cart data and ensures users consistently interact with the same server or retrieve session info reliably. SSL session ID depends on encrypted connections but may not persist across SSL renegotiation. Server memory C contradicts stateless design. Disabling persistence D worsens the issue. This question evaluates deep understanding of session persistence methods in application delivery. Question 22. By comparing various application security controls, which option best enforces rate limiting while maintaining legitimate user access during peak traffic? A. Use NAT to distribute IP engines across backend servers. B. Enable access control list on core routers. C. Implement token bucket algorithm at the load balancer. D. Offload SSL processing to backend application servers. Answer. Correct answer. C. Implement token bucket algorithm at the load balancer. Explanation. A token bucket algorithm provides rate limiting while allowing bursts, maintaining access for legitimate users. It balances fairness and protection against abuse. E.g., bots or DDoS. NAT A doesn't rate limit ACLs. B. It routers are too coarse-grained. Offloading SSLD reduce CPU load but doesn't limit request frequency. This falls under application security, specifically rate limiting and traffic shaping strategies. Question 23. In summary of an investigation into application slowness, logs indicate repeat TCP handshake attempts without successful connections. Istatech, a network analyst, suspects a protocol-level issue. What should be the first step to validate this? A. Examine DNS resolution latency. B. Analyze SYN and ACK packet behavior in network traces. C. Disable WAF rules temporarily. D. Increase timeout thresholds on backend servers. Answer. Correct answer. B. Analyze SYN and ACK packet behavior in network traces. Explanation. TCP connection failures often relate to issues in the handshake SYN-ACK packet trace analysis helps determine if handshakes are completed or dropped. DNS latency causes name resolution issues but not TCP handshakes. Disabling WAF C is risky and may not help. Timeout changes D are backend focused, not connection oriented. This is CPIP protocol suite and troubleshooting methodologies in application delivery. Question 24. To what degree does enable HTTP compression assist application delivery when serving large text-based responses like JSON or HTML to mobile devices on slow networks? A. It increases backend CPU load and hands delay. B. It reduces response payload size and improves load time. C. It replaced TLS encryption with smaller cipher sizes. D. It removes redundant HTTP headers from requests. Answer. Correct answer. B. It reduces response payload size and improves load time. Explanation. HTTP compression e.g. gzip broadly reduces payload size, which is critical for low bandwidth clients like mobile devices. This directly improves application performance. Backend CPU may increase slightly, but benefits outweigh cost. TLS changes C and header removal D are unrelated. This falls under acceleration and optimization with focus on bandwidth management. Question 25. Looking at the data on load balancing algorithm effectiveness, what issue might arise when using round robin in an environment where some backend servers are more powerful than others? A. All requests go to the same server, overloading it. B. Requests are unevenly distributed based on user geolocation. C. Less powerful servers may be overwhelmed, causing failures. D. It prevents SSL session reuse across requests. Answer. Correct answer. C. Less powerful servers may be overwhelmed, causing failures. Explanation. Round-robin blindly cycles through servers regardless of their performance capacity in heterogeneous environments. This leads to overloading weaker servers. Option A describes lack of load balancing. Geo-based. B applies GeoSSL reuse. D relates to persistence, not algorithms. This addresses load balancing algorithms and scalability considerations in application delivery. Question 26. The question remains whether improper use of NAT could interfere with security monitoring in an application delivery environment. What is a realistic consequence? A. NAT helps decrypt encrypted traffic for analysis. B. NAT masks source IPs, affecting forensic tracking. C. NAT improves visibility into microservices communications. D. NAT prevents TCP multiplexing on internal networks. Answer. Correct answer. B. NAT masks source IPs, affecting forensic tracking. Explanation. NAT hides the original source IP, making it difficult for firewalls, WAFs, and SIEM tools to trace malicious activity back to its origin. It doesn't decrypt traffic A, nor improve internal visibility. C. TCP multiplexing. D is unrelated to NAT. This is part of network address translation NAT under networking and protocols and its impact. Security monitoring. Question 27. While examining logs in a multi-region application deployment is new and identifies inconsistent client IPs in access logs, making geographic analytics unreliable. What's the most appropriate solution? A. Enable X forwarded for headers in the load balancer. B. Configure round-robin ENS for all users. C. Encrypt logs using 2048-bit SSL. D. Replace HTTP with WebSockets for faster connection. Answer. Correct answer A. Enable X forwarded for headers in the load balancer. Explanation. X forwarded or XFF headers preserve the original client IP when passing through proxies or load balancers. This is vital for accurate logging and analytics. Round-robin DNS. B. Doesn't help tracking. Encryption. C. Secures logs, but doesn't fix missing IPs. WebSockets. D. Are real-time protocols, not logging tools. This question addresses HTTP headers. Load balancer configuration in application delivery. Question 20. Historically speaking, fault tolerance was achieved through hardware redundancy. Today, which application delivery strategy achieves fault tolerance with greater flexibility and cost effectiveness? A. Server-side includes for dynamic web pages. B. Use of multiple NICs on the same server. C. Active-active load balancing across availability zones. DHCP 302 redirection to backup services. Answer. Correct answer C. Active-active load balancing across availability zones. Explanation. Active-active configurations distribute traffic between multiple zones, ensuring availability even if one zone fails. It is cloud-native, flexible, and cost-efficient. Server-side includes a outdated. Multiple NICs. B. A hardware-based HTTP 302 redirects. D. May introduce latency and don't provide true fault tolerance. This falls under availability and fault tolerance. Question 29. With respect to microservices deployments, how does a service discovery mechanism support effective application delivery? A. By caching or TLS handshakes for reuse. B. By allowing dynamic registration and routing of services. C. By assigning static IPs to each container. D. By blocking unused ports on backend servers. Answer. Correct answer B. By allowing dynamic registration and routing of services. Explanation. Service discovery ensures that as containers and services scale dynamically, their availability and routing are automatically updated. Essential in microservices environments. TLS handshake caching. A. Doesn't relate. Static IPs. C. Oppose container dynamism. Port blocking. D. Is basic security but not service discovery. This addresses cloud virtualization with focus on application delivery in microservices. Question 30. From multiple perspectives, implementing a WAF in front of a web application has which multi-layer benefit? A. Prevents all layer 2 switching issues. B. Ensures browser compatibility across clients. C. Detects application layer threats before reaching backend. D. Encrypts all outbound application traffic automatically. Answer. Correct answer C. Detects application layer threats before reaching backend. Explanation. The web application firewall WAF is set to traffic for known pattern associate, etc., blocking threats before backend systems are affected. Layer 2A is unrelated. Browser compatibility. B. Is handled client-side. WAFs don't encrypt traffic. D. That they may operate in SSL termination mode. This question covers WAF under security.